For this example, we want to graph these three functions on the same set of axes, noting the vertex and the axis of symmetry. So we're going to choose negative, 0, and positive. And for the basic f of x equals x squared, we know that's 4, 0, and 4. And it has this shape with the vertex at 0, 0. So 0, 0 vertex. The axis of symmetry then is going to go through the vertex at x equals 0. So let's look at g of x. That's 2 times x squared. So if this was negative 2, that's 2 times negative 2 squared. So 2 times 4 is 8. For 0, that's 2 times 0 squared, and 2 times 0 is 0. And for positive 2, that's 2 times 2 squared, or 2 times 4, which is 8. So that's going to go through here. That's g of x equals 2x squared. So our vertex is actually going to be the same. And our axis of symmetry is going to be the same. Then we want to look at the last function. H of x is 1/2 x squared. So h of negative 2 is half of negative 2 squared, which is half of 4. So that's 2. H of 0 is half of 0 squared. So half of 0 is still 0. And h of positive 2 is half of 2 squared. So half of 4 is 2. So we graph that on the same set of axes here. That's going to be negative 2, 2, positive 2, 2. So it's going to go out like this. H of x is 1/2 x squared. And you'll notice that the vertex is the same for this function as well. So all of these functions have the same vertex. That did not change because we did not shift horizontally or vertically. What did change is the coefficient. You'll see that the 2x squared, that graph kind of looks like it was stretched so that it's thinner. And the 1/2 x squared graph looks like it was flattened. So that's a shrink. It's wider. So the coefficient of the x squared is either going to stretch if that coefficient is larger than 1, such as 1.5 or 200. Anything that's greater than 1 will stretch that graph, pull it up so that it's thinner than a normal parabola. And the 1/2 made it shrink so that it was wider. So anytime your coefficient is between 0 and 1, which is a proper fraction, this will happen to your graph. It will change the shape a little bit. Let's graph some parabolas that are defined by f of x is a times x squared. So stretches or shrinks depending on what we have. If a is positive, then the parabola opens up, of course. If a is negative, the parabola opens down. That does not affect the shape. It just affects whether it opens up or down, if it's a positive or negative. So don't worry about the sign of a. It's the number that's important. So if that number is greater than 1, you're going to have a narrower graph. If that number is between 0 and 1, then you're going to have a wider graph if it's a proper function, a proper fraction. So let's graph these examples here. Label the vertex and the axis of symmetry. For 7, f of x is negative 1/3 x squared. So there's two things going on. There's a negative, which is reflect over x-axis. And there's the 1/3. So 1/3 is going to make it wider. It doesn't change the vertex because there's no shifting left, right, up, or down. So the vertex is the same, 0, 0. We're reflecting and we're making, well, it's only 1/3 wider, so 3 times as wide as normal. And if you need another point for your graph on the homework program, then just evaluate that function at a number, say 3. And you can get another point to graph that. So then we also need the axis of symmetry, which goes through the vertex. And of course that hasn't changed because the vertex hasn't changed. So axis of symmetry here, still x equals 0. Our next example, f of x is 2 times x plus 3 squared minus 4. So a lot of things going on here. There's no reflecting though, so this is going to open up. We have a horizontal shift here. So that's left 3 units. We have a vertical shift that's down 4 units. So left 3, down 4. And that marks our new vertex at negative 3, negative 4. And now we also have a coefficient here that's larger than 1. So this is going to be twice as narrow. 2 times, right? So 2 times as narrow as usual. There we go. Axis of symmetry then goes through that vertex so that x equals the x coordinate, which is negative 3.